Folks, today we are going to see vectors. So vectors deal with some quantities that have size and direction. Like this, we have a magnitude, it's a size, and this direction. It means we have here an angle here, and for example, we have this direction up. We can to have the opposite direction down, for example. So this is a vector when we can represent a quantity using a direction and a magnitude. For example, temperature, pressure, energy, and mass don't have a point to some place, so we call them scalars. So we can use something with magnitude and direction with this temperature, pressure, and etc. And adding vectors, the rule to add vectors, you use, for example, a plus b. You use this edge of this vector as an arrow. We have here the beginning of the arrow. We always put in the final of the other arrow. Okay, we can to see vectors as arrows. So we have here the edge of the arrow, always in the finish of the other arrow, and so we add it and have the r vector, the resultant vector a plus b. You always use this arrow here to represent when we will write the vector. So because why we use this idea of add vectors, for example, in force, when some people is pushing a person here and another person is pushing here, we see that this person have a force here and the displacement is in this direction. So when this vector plus this vector, we have this force here. So because it is something that explains because why we add this vector in this way. So we have this the commutative law. We can add a plus b or a plus b like this in these two ways, a plus b or b plus a, and we have the same resultant vector here. We have the associative law. It means, and we can do again, we have here the arrow, the edge of the arrow in the finish of the other arrow. Okay, a plus b plus c, we have this vector. This is the resultant vector, a plus b plus c. We draw another vector here. Okay, and here we have if we think a plus bc, we have a plus bc in brackets, or we can think b plus c is bc. Okay, a plus bc, it means a plus b plus c is the same of a plus bc. Here the same idea, a plus b, we have a plus b, and we have the idea of a plus b plus c have the same resultant vector. A plus b plus c is the same as a plus b plus c. Okay, we have the vector a, we have the vector minus a. What is the difference? The is in the opposite direction. Okay, the here we have a and opposite direction minus a. Okay, we have the opposite vector here. So vector subtraction, a minus b equal c. A minus b is c. Why? We have here the b, the vector b, and we change the direction here, plus b. A plus minus b, we have the vector c. Okay, change the direction here because it is minus. We have the other rule here, that is the sum vector. We have q plus p. We can project here a trace arrow, aqui a traced arrow. We have this traced here, and we draw here P plus Q here, and is the edge vector. It's another way to add vectors without to put the iron, the edge of the iron and the edge of the iron. We can put this trace here and this other trace here, and do a draw here to explain it. So we have here a solved example. Someone walk here and walk here, and how much displacement we have here. So you use the Pythagorean theorem to find 10.3 blocks. Okay, we have two arrows here, two vectors here, and we have this displacement here. Okay, now you stop here and try to do this exercise. Okay, so we have these explanations about the result here. Here again the explanations. Let's go to some more one exercise. Stop and try to do. I believe this is easy. Okay, 11 units, 5 plus 6. So stop now and try to do the exercise. I will solve now. The letter E because we have this iron, the finish of the arrow here, and we have the R. Same idea here. Another examples. Stop and try to do. I will solve now. The same idea, the 6 and 7. Okay, the idea of the final of the arrow, the beginning of the arrow. Okay, the arrow, the final and the finish of the arrow. Okay, that's it. Okay, thank you. Bye bye.